Today we're pleased to interview one of the pioneers of programmable logic, John Birkner. The two interviewers today will be myself, Jesse Jenkins.
And myself, Jeff Katz.
Yes.
Hi, Jeff. Hi, Jesse.
Thank you. John, we've had some discussions and we've sort of, the gist of this is going to get to the development of PALs and all that, but we want to get to the roots of it. So to do that, we need to sort of develop some background on yourself. So we'd like to find out, where were you born and where did you grow up?
So I was born in Akron, Ohio, and
I'm a Cantonian myself.
yeah, okay. It was during the war. My mother and father both worked at the Goodyear Aircraft, building P-51s or some warplanes. And it's funny, later I worked in that same building. But that was kind of the beginning. After the war, they acquired a red Willys Jeep surplus, Army surplus, and drove it to California to find their fortune. And after a while in Southern California, father got gold fever.
Yeah.
And I think I must have been 6 years old, we went to live in a gold mine in the foothills of California near Yosemite.
Did you find any gold?
Oh yeah, we had a gold dredge, and we were suctioning up the sand, putting it in buckets, and you put it in a big bucket and put it on a pulley to shore from the Chowchilla River, and then with the Jeep we'd carry the buckets up to the one-room cabin, and where we had a shake table, and you fire up the engine and the table shakes, and you pour the sand and rocks in at one end, and it shakes everything down to one edge. And then that one edge you put in a gold pan, and first thing you do in the gold pan is with the tweezers, you pick out all of the nuggets and put them in a jar. And then the rest, you get the gold dust down and get all the black sand out, and then pour mercury into the gold pan, and it would suck up all the gold dust.
Dissolve it.
And then you would send this bottle of mercury to Sacramento, and they would take the gold out and send the mercury back with a check. So those were exciting times for a young boy.
It's interesting. That was a fairly interesting exposure to processing and steps of refinement.
Yeah.
Yeah.
To think back. Yeah.
And where did you go to school in those days?
So I went to a one-room school in Aulani, California, and every year you would move up a row. So you always knew what was coming in the next grade because you could hear it from the previous year. And we had a little library. I think the library came around, and I found this book, The Boy's Book of Electronics.
Oh.
We have a copy of that, or I have seen a copy of it.
Fabulous. My wife actually found a copy of it for me and bought it and gave it to me for a Christmas present. That was just a golden book. I had visited my grandparents back in Ohio. We would go to Ohio from time to time. And my grandfather was a pioneer radio builder in the city of Kent, Ohio, where he built the first radio. And when there was one of the first baseball games broadcast from New York, the whole town came to his house to listen to the baseball game.
That's
his
so cool.
radio that he built. So he had all these
Celebrity.
radios in the basement and motors and wires, and that really got my interest. And I remember bringing home some motors, and I found that book, The Boy's Book of Electronics. It had all these experiments, and the proudest thing I built was a telegraph. So with a tin can, to make the connection, you cut up the tin can and you make this little snapper thing. And some wires, and batteries from the flashlight, and you string the wires out to your treehouse, and you can telegraph your brother from your room. That was so cool. There were a lot of experiments in that boy's book of electronics. I'd like to see that in the museum if you can.
It must be up
dig
in
that
the
up.
library somewhere, yeah.
Yeah, so that book really influenced me.
That's great. So you mentioned the school in Aulani.
Yeah.
I know there's a famous hotel in Yosemite Valley named the Aulani. Is it the name of an
There is a
Indian tribe,
connection. The Aulani Hotel is actually in Yosemite. The town of Aulani is, it's a few miles out.
Mm-hmm.
And Aulani is spelled A-H-W-A-H-N-E-E, which you learn when you live there as a kid.
Mm-hmm.
And there is a street called Aulani in Sunnyvale. It's spelled wrong.
Well, maybe we should do something about that.
It was the Aulani Indians in
Yeah.
Yosemite.
I've read that the new proprietor in Yosemite is renaming the hotel because the old proprietor owns the name Aulani and wants too much money to,
Oh my gosh.
to license it back to the new manager.
Mm.
And the Indians have nothing to do with that, right?
So that also, well, maybe that's more modern than it was then, but the intellectual property is a big issue today. Maybe it became
I'm
one
sure.
then.
Continuing that story from Aulani,
Yeah.
my father, he joined the California Division of Forestry,
Mm-hmm.
and he loved the outdoors. And the first place we went, we lived in a firehouse.
Mhm.
There were 2 fire trucks parked in the back in the garage, and my brother and I, we had so much fun.
Did you have a pole?
No, there was no pole; it was all flat. So living in a firehouse, that was great.
Did you actually have to fight fires?
Later on in life, in my college jobs, I worked for the California Division of Forestry, the summer jobs, and yes, we fought fires. And the peak of that was after 2 summers, I got to be on the helicopter crew in Garberville, California, and we would sit on top of Pratt Mountain with the lookout tower, and we would wait for fires.
Mhm.
Just look down. And I remember this, one time we spotted this fire, and we jumped in the helicopter and we swooped down, and there was a farmer. He had his tractor and his torch and started a fire, and you could just see it in his eyes later that his whole ranch was going up in flames. And this helicopter comes out of the sky, and these firefighters jump out, and they had their backpacks and their McLeod. So McLeod was a tool that had a hoe on one side and a rake on the other side, and we made a line and put that fire out. Oh, that was
Like
exciting
superheroes.
Well,
and then the downtime, I would go up into the tower, and I'd do various things. I would drop rocks and count the seconds that
Mhm.
rock took to fall. And I
Trying to
was
estimate.
studying physics at the time, S equals 1/2 GT squared
Yeah.
to prove prove the acceleration of gravity. And I would also use Drano, a mixed Drano with aluminum foil and water, which of course makes hydrogen gas,
Mhm.
which you can use to fill up a balloon, and I would fly balloons from the lookout tower.
well, that kind of a background may give you a good grounding in resourcefulness.
Yes.
Living out in the wilderness, you got to make do with what you have, and you
Oh, yeah.
start thinking about how to get stuff done.
Oh, yeah.
For sure. Yeah, at the gold mine, we were not doing too well, and there was a big storm. It came, and the lake above us filled up, and it overflowed, and all the fish came out. And so the stream bed was just covered with fish, and we went out and gathered them up. And my mother always told that story, that when we were down and out, there was a storm, and we gathered up all the fish, and we ate for another month.
Excellent. It's totally resourceful.
Yeah.
I love it.
Did the schools you went to out there in the wilderness give you any scientific background?
I would say they were pretty much California public schools.
Right.
I remember we had the projector and the films would come on rotation, and watching California history on the projector. California schools were very good.
They were very good in those days.
Yeah.
What about high school? Did you go to the same place?
I went to Reedley High School in my freshman and sophomore year. That's out in the San Joaquin Valley. And I joined the band. And,
What did you play?
I played the trumpet.
Oh,
Yeah, it was
you
fun.
enjoyed it? Yeah.
I was in the brass section too.
Yeah.
I played the sousaphone.
Oh, okay. And next we moved to another firehouse in Crescent City, California, where I went my junior year and met my first girlfriend, fell in love, and then moved to yet another firehouse in Fort Bragg, California, north of here, near Mendocino. And a story there in high school. So I was always a new kid, and they were having an election for senior president, and some of the new kids would say, "Hey, why don't you run?" I said, "Okay," and so I gotta have a gimmick. So I had met this fella who had a little tiny sports car. He was a MC at the local radio station. I said, "Can you drive that car down the auditorium where I can give my election speech?" And sure. So that was a big hit, that I was the only candidate who pulled off a stunt that in the auditorium arrived in a car.
You made an
And
entrance.
I won the election by 1 vote. So I was senior class president in a high school that I had just been there for a month.
You arrived in style.
I did.
So, John, granted, you're living out in the wilderness to a large degree.
Yes.
I mean, out in the edge of civilization.
Yes.
What other things did you do for fun?
Oh, of course, hiking and
Right.
walking in the river and capturing snakes, shooting BB guns, and of course we hunted for food, quail, deer, and we had guns, but we never felt they were dangerous.
No.
Everybody has a gun.
Sure, absolutely.
Don't have any guns now, but
Yeah.
back in the day, that's the way it was.
So you were also doing experiments with your handbook for boys or whatever it was?
Oh, yeah. Always doing some kind of...
What were your best and worst subjects in high school?
Of course, my best was science and chemistry, and mathematics. Oh, I love geometry.
Pure logic, yes.
Fascinated.
Yeah.
That would turn you into a logician. Yeah.
Yes, I remember later on getting a book by George Bullion, or Bull. I'm George
Bull,
Bull, and making a lot of quotes. I think I quoted in the Pal Handbook quotes from George Bull, and the syntax. George Bull's syntax. I really studied his syntax, the characters that you use. So what is A times B? You write AB. That means A times B, right?
Right.
But that computer's not going to understand AB. You want a symbolic name like VCC or something. Okay, you got to pick a multiply term. So I picked the star, and then. You got a sum, an or, A or B.
Yeah.
I picked the plus.
Right.
George Bull used a plus.
Right. Now, what you're alluding to is later when you develop the
Yes.
Pal syntax. Yeah.
Yeah.
So when you were in school, clearly you liked science and math.
Oh, my favorites.
What didn't you excel at?
Spelling.
Really?
Could not. Still can't spell. It's.
But now you don't have to. Google does it for you.
Yeah.
Or Word?
I did like to write. I remember my term paper, I had like 100 spelling errors or something, but I still got a good grade.
So the creative aspect of writing you liked.
Yeah, but I later on in college, I thought, oh, no more English. But in the junior year or end of sophomore year, they said, well, we got to check all these engineers, make sure they can write. And I failed, and I had to take what would they call it, bonehead English in my junior year.
It's like subject A was what it was.
Oh, that's right, subject A.
In the UC system.
And I passed it, and it really was beneficial. I had a good subject A teacher, and I remember a lot of things about writing. Something as simple like, there's no fixed rule for a comma. You can use it or not use it. It's not.
It's interesting, yeah.
Yeah. In my college, we had to turn in our lab reports to two teachers. One was the lab instructor for the science, and the other was an English instructor for the writing.
Oh my gosh.
Really?
Where did you go to school?
We got 2 grades. That was at Case Tech.
Okay. Yeah. Good.
Which you would know about.
I would know, yeah, about Case, a very famous engineering school. But I remember taking the first engineering courses. You had to keep your lab books, and you had to print very legibly, and there was a standard for printing. The letters had to look like this. And so we'd take very careful notes, and you couldn't erase. You had to cross it out. So all errors were known.
Everything had to be done in ink.
Yeah.
Classic. Yeah.
You mentioned UC system. Is that which UC did you go to?
Excuse me?
Which you said you went to UC?
UC Berkeley, yes.
Berkeley, okay.
And I love that first engineering class. What was that called? Engineering 101 or something. We had to learn to draw and one of the projects we had to measure the distance between the top of the campanile and a church spire by using the transit. And so we slide up the transit and get all the angles and calculate the distance. And it was like a half a mile or something. And I got an A. I must have been close measuring that distance.
Did you have any particular teachers or professors there that were major influences on the rest of your career?
Donald O. Peterson, who later became the chairman, very famous. He taught the first course on transistors. And he was converting the course from vacuum tubes to transistors at the time, so he didn't have his new book ready, so we had all the chapters of the book
Handwritten, probably.
Come chapter by chapter on all the Ebers and Moll equations, how does a transistor work, and those were fascinating days, and he was so excited about moving to transistors from the vacuum tube. So I got a little bit of vacuum tube theory also. And then another teacher, Professor Evans, and I'm thinking it was Evans in Sutherland, but I don't know if I made that connection or not. But he taught the first computer science course before there was a computer science department. And I loved that class. And the first assignment was design a processor and simulate it in, what else? Fortran. And so we had the accumulator and the decoder and all the basics of a computer, von Neumann architecture. And we coded it in Fortran, and then we typed it up on IBM cards, and we did 1 job a day. And the class had a certain amount of computer time allocated to it, and I used it all up. The professor was complaining I'm using too much computer time. And I did one favorite program was to forecast the full moons for the next 100 years. Wow, that was so fun. And just write the equations for the period of the moon. And,
of course, to check the accuracy may take some time.
Yeah. And we had to, if you made a mistake on that card, You'd have to run it again the next day. I used up all the time.
Gregorian or Julian calendar?
I think I did take into account the leap year.
Wait a minute, what about the Mayan calendar?
Well, yeah, there were many calendars. And very accurate predictions, too.
So I'm getting an impression that your early training in self-taught for basic electricity and then early transistor work and early computer science really resonated with you. And were you able to take more classes along those lines later from Berkeley, or were they just too early?
It was quite early, but I did take everything there was possible on computers. I enjoyed physics. I enjoyed circuit theory. And in my latest job, I'm having to relearn all of that. And I have circuits in my head. And amazingly, I have been using Excel to write circuit simulations. And you just write all the equations. And
Excel does equations.
It does.
Yeah. No, it's interesting what Excel can do. It's an interesting tool. So, other hobbies and things that you might have had an interest in, did you pursue the trumpet beyond high school band, or do you still play at all? Or
No, I did not.
Okay.
I did not carry on the trumpet after high school.
So you have another hobby, though?
I love photography. I've always loved photography. I have expensive cameras, but now the cell phones are getting so good,
Yes.
and you want to publish them instantly. And now everybody is a photographer, so it's not so novel anymore to be a photographer. But I've always enjoyed photography.
It seems so strange to me that photography has become, I want to call it computational photography, that they're photographing around corners and they're taking the reflections off of windows and stuff like that.
Oh, yeah.
It's like it used to be that you'd have to set things up to make that happen, and now it's being done technically. So we know that you were interested in electronics from this one book. Were there any other books along those lines that you can recall that really captured your imagination and gave you any inspiration?
I remember in high school keeping up that theory of going to the library. Wow, I think I want to be an electrical engineer. What can I find on electrical engineering? And most of what I read about was power lines.
Oh, yeah.
So at that point, I wasn't able, and then we had an encyclopedia. I would read anything in the encyclopedia on electronics. But there wasn't that much available back in the day until I got to Berkeley.
Interesting. You were also a bit isolated. You had radio and stuff, but you didn't have as much TV and stuff available to you,
we were
right?
out in the countryside.
Yeah, no, that.
So it was a great experience to leave Fort Bragg, which was a lumber town, sawmill, and not much of an academic focus out there in the wilderness.
Yeah.
Everybody grew up to be lumberjacks. But I had a passion for science and electronics. And let's see, I built a Heathkit radio. Oh, that was 7 transistors. That was big. Heathkit.
Oh, yeah.
Was big.
I did a Heathkit based on tubes.
Oh, okay.
Yeah.
I had a crystal radio. I remember in my bunk bed, I had the wire coming around, and you had to wrap coils around toilet paper rolls, and then you can have a slider,
Right.
But getting the crystal, and then you had the cat whisker, and you put that down there to make that diode.
Oh, yeah.
And then you had the headset, and that was really fun.
So you got to do personally a lot of little hands-on things, like I assume you did your own soldering and cutting and all that stuff to build a. Were you able to transfer any of that to your daughter?
It's a funny thing. She's now a lawyer.
So is mine.
I just wondered. Yeah.
It didn't really resonate with my daughters.
Yeah. Okay.
It's strange, but they are computer whizzes
Oh, I'm sure.
in their own right, but they didn't pursue the
Yeah.
technology.
Interesting.
Their mother was much more vocal and outspoken, and she became a lawyer.
So, at Berkeley, did you run all the way through the 4 years and then go get a job, or did you go on to graduate school, or what?
I did 4 years, and I got 20 job offers.
It was a good time in those days.
That was a great time. I remember Boeing sent me a job offer to go to work in Seattle on the SST or something, and I hadn't even interviewed with them. Fairchild Semiconductor gave me a job offer to work in a diode factory, and I said, I don't think I want to work in a diode factory. But my family had moved back to Ohio, and I wanted to be close to them, and this opportunity to work at Goodyear Aerospace. They changed their name from aircraft to aerospace in modern times. They were doing pioneer work in analog computers and parallel processors. They had a lot of money, and they were doing research, and it was convenient. And so my first job was there, and I worked for Charlie Blust, who worked on the IBM, I think maybe it was 1404, I can't remember, in Poughkeepsie, New York. And he said, oh, why don't you come to work for us? We're doing really exciting work. And we were. We built parallel processors, and we had projects with the Advanced Ballistic Missile system, and I went to Kwajalein and installed a radar, and I went to Knoxville, Tennessee, and installed collision avoidance hardware and FAA, and they would test them by flying airplanes at each other, and then at the last minute, and they wanted to see if we could detect that they were going to collide. I got a really good experience.
Did you use actual airplanes and real live pilots?
Jets, airplanes.
With human beings
Yes,
at risk.
And they would just be, and we could watch them on the radar and watch our software detect beep, 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 collision.
And the next thing you hear is
So it's 40 years later, we're doing it in vehicles, ground vehicles.
That's right. Oh, so
I got off on a tangent there. How did I do that?
Going back to college for a second, you had mentioned that, that you had a course with Donald O. Peterson.
Yeah.
And you'd gotten some of his earlier notes and stuff like that.
Yes.
You didn't keep them, did you?
Oh, no, I didn't keep them. No, didn't.
I don't remember who all the big players were then. As I recall, Fortran was the language of the time.
And Algol was
was the scientific language. Fortran was commercially used for scientific stuff, but the academic world loved Algol, which ultimately became Pascal and later C.
Yeah. I remember I wrote a paper in Pascal. I thought that was kind of novel. The paper was at WestCon or something, and it was all about this compiler. And so I inserted the paper into the compiler as it presented the compiler, which had the paper in it.
So how did you make the transition between working on radar avoidance systems and so forth in getting into integrated circuits? You did go to graduate school.
Oh, that was the question. Yes, while at Goodyear Aerospace, I went to, I got a master's degree at the University of Akron, not very well known, and a thesis was not required, but I wanted to write a thesis, and my thesis was plated write noise relaxation and a plated wire memory. So we were using plated wire memories and reading them in a 100 nanosecond cycle, which was very fast back in the day.
Speed of light back then.
Yeah. And access time was very critical, but there's always noise after a write. So you do a write pulse to flip all those domains, and the noise would last for microseconds. Oh my God, how do you get it out? What is it? What is this noise? So I did a research project to figure that out, and determined that when you pulse a wire, you make a lot of eddy currents on the edges. Of course, the current doesn't go through the wire; it goes on the edges, on the outer portion of the wire, and it gets eddy currents spinning up on the edges of the wire. And after running a few hundred milliamps down that wire to flip it, and then you're going to sense millivolts, all those eddy currents are still curling around, going and making noise, and how to reduce that. And so I looked at a number of methods for reducing it as my thesis, and came up with if we put some, I think it was graphite, in the coil windings, it would absorb some of those eddy currents.
Interesting.
But then differential sense amplifiers just really refined that and got the right noise down to, I think it was 2 memory cycles, 200 nanoseconds before you could read it. And
You know,
so I got my master's degree.
that was pretty cool back then, though. You know, it was.
Yeah. And then wanted to come back to California.
Yeah.
And I had my adventures out there in Kwajalein and Knoxville, doing real engineering in the field and very creative engineering. A lot of kids come out of school and they go to work in a big company and they do graduate rotation or whatever, and they're
Sit
not
at
in
their
a
desk
creative
most of the time.
environment. I was, right deep into the creative, doing design and going in the field. And I took this computer out to Kwajalein. I was the only guy installing this computer on the ABM anti-ballistic missile system. They had a phased array radar, 5,000 elements pointing up in the sky, watching this missile take off, and it would do telemetry to the missile as it was taking off. And these missiles, they would be gone within a second of your view. I mean, God, you're 3 miles away and it's just gone. But the phased array radar could track it. And there was the curvature of the Earth that was causing some kind of errors. And so our computer would do the error correction and very, very fast. That was the requirement. But unfortunately, when we shipped the computer out there, it was all wrapped up in these metal wires, and but they kind of look like the bus bars that were for the power distribution of the computer. And when the locals unwrapped the cartons and they saw all these bus bars, they thought it was trash, and they took it.
Oh no!
They took it to the dump and burned it immediately. So I was trapped on an island in the Pacific for 3 months, waiting for the new bus bars to arrive.
Wow.
It was glorious. We did sailing and collected seashells and got a nice tan. And
You got paid for it.
I got paid for it.
Beautiful.
That was a great tour of duty. But I wanted to get back to California, and I went to work for Philco Ford Aeronutronic in Newport Beach. And when I was kind of looking around, and I drove up to their facility in Newport Beach, it overlooked the bay and the ocean, and I said, I want to work here. I didn't care what the job was. I want to work here. This was so cool. So actually, it did turn out to be a good job. I used my experience to do digital signal processing on some contracts there. And one of my jobs was to buy a commercial computer for a military installation in Alaska. And I did a survey, visited many computer companies, and then decided to buy a computer from the computer company down the street, Computer Automation, which was in Irvine. And they were building mini computers, and they really liked me, and I thought, oh, this is cool. And I thought it would be, I got all this great experience working in the military industrial complex on these big projects, getting great experience, spending the taxpayers' money. What about being in the commercial sector? So I crossed over and went to work for this mini computer company and designed processors. It was such a fun job. And that's when mini computers, the Digital Equipment Corporation, the PDP-11, all those mini computers were being built at that time, Data General. So everybody was building their own computer architectures. And for this company, Computer Automation, the name of the game was low cost and small size. So their first generations, they took 2 computer cards, they were about this big, to make a processor and a memory card, and they were selling them to banks. Barclays Bank in England was a big customer, and we were trying to get them smaller and smaller. So my assignment was build a processor on a half card. Okay, this is a card is this big, but they wanted a half card because they had half card memories, and then they could stack the 2 half cards, and it would fit in a bank terminal, you know, the credit card, automatic money dispenser, whatever you call it, in Barclays Bank. It had to be a certain form factor, a certain size. So I had to get that computer down to be small. So the name of the game, how do you design a processor that's on this big? And you've got to have an accumulator, and you got to register files, and you have to have a decoder, and you have to have I/O and memory interface. And we're going to do it with TTL. And so you got to put all those chips in there. So the job for a computer architect was a puzzle piece. How do you hook all of these integrated circuit chips together on one PC board and get it to fit on the board? And
how many layers did you have? Do you remember?
4 layers.
4 layers, okay.
And get all the features that marketing and software wanted in there. So the only solution was a microprogram machine. It was very much like the bit slice, only I used Texas Instruments 74 181 ALUs, and I used monolithic memories, 16x4 memory register file. And
That's the SRAM or the EEPROM?
It was a RAM, SRAM, and Intel made them also. And in fact, so I remember H.T. Chua with Bob Noyce was one designed the first. I think it was the 256-bit.
3101.
3101. So H.T. Chua came to MMI, and he was designing some memories, and.
You're not at MMI yet.
No,
You're still at CAI.
Before you get on to MMI, I want to go back to these first few jobs you just mentioned. You know, the aerospace 2 jobs, and then moving into the mini computer world.
Yeah, that was.
Any particular mentors that gave you major insights that you used the rest of your career?
Oh yeah. And why can't I think of his name right now? Computer Automation. He later became Intel, and now there's an award for. I can't remember his name.
What, Phil Kaufman?
Phil Kaufman.
Yeah, I knew he
was
came
my
from
boss.
CA. Yeah.
He was very inspirational and gave me a lot of guidance on computer architecture. And any other inspirational fellows? None come to mind. I was just having so much fun designing computer architectures. That was my passion.
That's great.
And to be able to design a processor on one card. You know, and that architecture really did compete with the then coming
PDP-11s, that kind of thing.
Intel 4004, 8080, whatever. In order to put an 8080 on on a card or an 8051 like Steve Wozniak did to make the Apple I computer. You had to have all these other chips all around it, all this support, the memory interface, the I/O. So yeah, you got a single chip computer, but what are those 40 other chips around it?
Oh yeah.
So my processor, it just didn't have. It didn't have the 8080 in it. It just had the 74180, 181LU, and all the MMI proms for the microprogram store. And that made a really fast processor. And
I was going to say, I know that the Data General processors all had 181 ALUs in them. And
So the SEL one that I built.
okay,
And it had MMI and Signetics proms.
interesting.
That had Intel SRAM.
Okay.
They were faster.
so
Yeah.
something is
those were the
about to
days.
happen in your career, though, that's going to have you shift from there to getting into the integrated circuit world.
Yeah.
What? Get laid off?
Oh, no. So I was just having a really great time designing those processors, and that process is called the computer automation. They made naked mini computers. They would just sell the boards.
Yes, yes.
And the banks like that.
I think they used that term, didn't they?
Naked mini, yeah.
The naked mini.
However, they really wanted a smaller one, so I named it Naked Millie. It was smaller.
Yeah.
So I built a Naked Millie, and I worked on the Naked Minis. And I later discovered that Naked Millie in the British Museum as a Barclays Bank example of one of the first automatic tellers.
That's fun.
Yeah, so processor design was.
All right, so you're at computer automation, making processors,
Yeah.
and you're using some chips.
Yeah.
How'd you end up making that switch from system to chip?
Yeah, so I'm using the chips, and of course, I'm the target for all these semiconductor salesmen who will do anything to get the order. I remember this one very aggressive salesman, Larry Jordan. I don't know, maybe you even know him.
Larry.
He was a salesman in Southern California, and he really wanted the order. He would just come in, and I was a little bit gullible engineering, and he would say, well, take me over to your prom department. Show me what proms you're using. And you don't want to use the Signetics proms. You want to use these MMI proms. And sign here, place the order. He was just forceful. Then there was another salesman, Russ Allman, who drove this Bentley or something. I mean, these salesmen were rich.
Yeah.
And they would take us sailing out in the bay and get us drunk and take us to dinner. So decision makers at the computer manufacturers were just targets of these semiconductor salesmen. And they were always promoting whatever. And so I really got to know the semiconductor companies. AMD and MMI and the bit slice. So they were pushing the bit slice, but I looked at the economics, and now this bit slice is too important. Signetics was pushing the FPLAs to do the memory instruction, or the instruction decoders. Well, it's a logical thing, a PLA. That's the best way to decode an instruction. Use these PLAs. And I just couldn't justify the cost, the size of those big packages, and the propagation delay was not fast enough. No, didn't do it. But it kind of gelled. Oh, maybe I should go up there and tell them what they need.
Oh, yeah.
And wow, computer design, 8080, Intel. Computer architecture is going to be, I'm going to be a dinosaur here pretty soon if I don't go to a chip house.
Interesting.
So, handwriting was on the wall. Everybody was designing computers. They were designing their own instruction sets, their own languages. But it was getting standardized, and it was going to happen at a semiconductor company, not at DEC or Data General or computer automation. And so I was kind of looking around. And I remember reading two magazine articles, electronics. One was by Jerry Sanders about his company, and the other was by Zev Droy about his company, Monolithic Memories, and they were promoting their companies. And I had the 2 articles. I read them. So I went and interviewed both of them. I flew up in a Cessna 150. Had a funny story there. I was renting this plane from a pilot, and I was flying along and looked down this side of the airplane. It was all black. Oh my God, why is it black? So I landed and looked at it, and I called the pilot, and he said, "Oh no, that's a normal oil leak. Just keep putting oil in, and when you get to San Jose, call Joe, and he'll fix it." So I thought all these cans of oil, I was landing every hour, and all these places, and flying up the San Joaquin Valley, and I got in later than I had anticipated, and I couldn't find the light switch to turn on the lights. Oh my God. Can't see the switches because it's dark in here, and I forgot my flashlight. Pilots always carry flashlights, but not in the daytime. You don't need a flashlight in the daytime. I'm coming in over San Jose, and this airplane's getting on its last leg. I was getting ready to declare an emergency. I didn't know if I was going to. I kept losing altitude. Fortunately, I anticipated that it's going to get dark. I better dial in all the frequencies. So there's 2 radio frequencies you need, far and close. And so I had the radio frequencies dialed up right, and I could switch them. And I just barely got into San Jose. Did my job interview with Clive Guest at Monolithic Memories, and John Mick at AMD, and they were both after me. I was being pursued. How wonderful is
Cool.
that?
Yeah, definitely.
The chip companies figured out they needed system guys because they didn't know what to put in the chips.
Yeah.
Right.
And when I did choose MMI, because I thought that was the best opportunity, and the supervisor was Clive Guest, who was a pioneer in his own right. If you don't have him interviewed, he invented much of 7400 TTL, which TI renamed from Fairchild part numbers when he was at Fairchild. So, and he's got stories to tell. I mean, he was in England when the bombs were falling, and they were inventing computers, and so he just knew all this computer stuff from England. And he was helping, well, at Fairchild, being the application engineer, designing all of these serial parallel multipliers and a lot of this TTL, which TI copied. And I could learn a lot. You know, you ask who was influential. It was Clive Guest. It's very influential on me. And so I decided to go to work for Clive Guest at MMI. And let's see, where were we?
All right, so you got into the industry. What was the first thing they asked you to do? Not design a computer, I presume, or what?
First thing is they handed me this deck of slides on this 6701 bit slice, and go back to Southern California to the WestCon show and give a paper.
There you go.
I'm in sales. I became a marketing person. So I was the only application engineer working for Clive Guest, and of course he was a director or something. He wasn't going to go call on customers. So I was the point man for MMI, who was making proms, and they were trying to get into other markets, RAMs, and this bit slice concept, which came from Clive, and the bit slice really did come from MMI, from Clive, and then
no, that was my first exposure to it.
then AMD renumbered it,
Yep.
changed some things, and Mick and Rick took it. So there was competition there. So I was doing the bit slice, and of course that was my expertise, processor design, and hopefully that would sell more memories, proms, for the microprogram store, which would control the bit slice. And it was a big business, a lot of military computers being built, mini computers being built, and that was the way. And
I think that was part of the early Intel model too, was that these processors can help us sell more memories.
oh yeah,
You know,
It was definitely the main reason for the process.
Yeah.
and then the memory drivers were the big cash cows, right?
Mhm. So one of the things that I vaguely recollect, and you can correct me on this, was that the FPLA, which I know the guys at Signetics and some folks at Harris were doing, was originally taken as a way to do the same thing as building truth tables in proms. But someone had noticed that the prom truth tables had huge spans of zeros in them or something like that, and that wherever the ones were was where you were going to create the logical event, if you will, and that someone said we can do that in a more efficient way. Is that consistent with anything you ever heard?
Oh, absolutely.
Okay.
The PLA was well known. In fact, I remember going to a museum in Boston, one of the early computers. You could walk into this PLA. It was all made out of big diodes and wires, and that was the instruction decoder for one ENIAC or something. And that's how they decoded in instructions. It was with a logic array, programmable. Harris was one of the first semiconductor companies to make a PLA on a chip. It was mask programmable. And then later, National Semiconductor, they made one of the first TTL PLAs, and it was organized 14 by 8. 8 being the number of bits in ASCII code, and 14 being the number of holes in an IBM card. And it had 40 product terms, which was half of the IBM card, 80 columns. So you could do 2 of them and decode an IBM card.
That's consistent with some things I had heard too, that they were related in that way.
Yeah.
It would take 2 chips to equal the complete
Decode the
complete
IBM
decode, yeah.
card. And at some point, the idea was to make it programmable using PROM technology. Signetics was doing that. I don't think National ever did. Dale Mrazek was the guy at National who was promoting that PLA concept. And so at Computer Automation, I was looking at those PLAs and considering using them, but they didn't meet the right performance.
Okay.
And
I was going to say the early PLAs were in the neighborhood of 40 nanosecond prop delay or 50 nanosecond.
50.
Yeah, it was
Too slow.
Yes.
For the TTL of the day, which was in the 20 nanosecond kind of range.
Yeah. Interesting.
So I was running around promoting those bit slices and proms, and one day, Clive Guest comes into my office and says, gee, what do you think of these PLAs? Can we make enough PLA? Why don't you look at that? And that's when the wheels started to turn. Taking all my experience designing TTL, having the 7400 gold book of TTL, a few hundred different components all memorized in my head because we had to work out those puzzles on the PC board. How do we cram, how do we do Boolean minimization when you really can't minimize? You've just got these chips that are already pre-configured. You've got 2 4-input NANDs, or you got 4 2-input NANDs, or 2 4-input NANDs, or you got some ORs. You really couldn't minimize, except with your brain, your head, to minimize the number of chips on the board. And it just struck me one day, this whole book of 7400 TTL, combinational and sequential circuits could be put in a few chips.
Mm-hmm.
It just struck me. All these AND gates and OR gates, they can just be crammed into this PLA.
Right.
Well, I already had the concept, a PLA could do that, but I had never been given the task of, well, what would be a good product that computer designers would use. Right. So I was fresh from being a computer designer, knowing the needs of space and cost and performance, and also now knowing proms, knowing the architecture of the proms. And in the PAL handbook that you have here, I drew the architectures of a prom, and I drew the architectures of an FPLA, and I drew all the little fuses. I used X's. These are all the little connections. Yeah. And you look at those two architectures, and the cost of this was too much. The performance is too low. What if I just took this prom and flipped it, made the AND array the OR array and the OR array the AND array, and come up with kind of a hybrid between these two architectures? And I drew it, and I drew this new PAL architecture in the center, and that's in the handbook. And that really gelled with people who wanted to understand. They could see the prom architecture, they could see the PLA architecture, and they could see this new thing. Right. And this new thing was fast and cheap and small. Yeah. And I remember spending a lot of time drawing. We didn't have computers to draw things. Draw these lines. Oh yeah. Drawing these lines. I remember in the basement, or the first floor of MMI, down by the mailroom, I had an office down there. I think you had an office down there too. And
I did for a while, and then they stopped doing the mini computer on a card. They're trying to do the Naked Mini or the Naked Millie, I think, out of 6700s. And that was my job but I was only there for a month when they said, "Nah, that's taking too much money. We'll never get to our IPO if we're spending that money." And they put me upstairs with you.
Oh, okay. But for some reason, I have these visions of being downstairs and working late into the night, and I'm the only guy in the building. And I'm drawing these lines, X's.
That's your punishment.
No, it was my passion.
I know. You were young.
Where did H.T. Chua come into it? Was he part of the concept at the beginning, or did you finally get the concept down and you say, "Oh, I need a circuit designer"?
So he and I joined MMI about the same time. I think it was September 1975. And he was an engineering guy. And actually, there were some other projects between that. Clive had said, "Oh, let's build a multiplier. 8 by 8 would be good. 8 times 8 is 16 out." And he said, "Well, read some papers and see what's the best way to do this." And so I worked with HT. He said, "Work with HT and design this multiplier." And so I read some papers. What's the best way to do this multiplier? And of course, we drew everything out by hand with these logic templates, AND gates and OR gates.
Little green plastic.
Yeah, green plastic, mill standard format. And then I got a timeshare computer, and I simulated it. And I put in all the combinations of 8-bit numbers times 8-bit numbers to make sure that I got the right answer on the output. And simulated all those gates in Fortran. And so I was working with HT, and then Clive came in one day and said, "Oh, let's build a 16 by 16 multiplier, but make it sequential, and also make it divide." Okay, and Clive did a lot of the inspiration, but I did a lot of the drawing. And so we built a 16 by 16 multiplier divider, and I simulated that one. And
did these make it to silicon?
Excuse me?
Did these?
Oh yes, they did,
Okay,
and they made it to customers.
Good.
And there were a few of them out there. TRW was our big competition. They had made an 8
Yes,
by 8
I remember that.
multiplier. And so that's what we were doing in applications in those days, is thinking up new logic blocks that we thought customers would need, or customers would say, I need this. And
Did you go out in the field and test the ideas with the customers?
oh yeah.
Yeah.
Yeah, I was out there promoting the proms, and the salesmen loved me. They would be sending me all over the world. And go give a paper here. Here's a box of slides.
Yeah.
The pals were not tested that much on the customer, though.
So, in my background, I was on the other side of the street working in a competitor.
Yeah.
And one of the, I would hear people saying, oh, those guys at MMI, they're doing this. We got to worry about them a lot, and you guys were starting to take off. And one of the comments that they'd made was that you had managed to be faster than an FPLA by removing one of the programmable aspects. And I remember that the negative comment that someone had made was, oh, they just did that to improve their yield. And I'm sitting there going, well, it also gave them speed, which apparently people needed. I just thought it was sort of an interesting thing. Was there a yield aspect to it, or?
No.
There wasn't, okay.
Not a yield. It was just, you had 2 arrays.
Get the job done in fewer chips.
Yeah.
Yeah.
Programmable and array, programmable or array.
Yeah.
We just cut the programming on the or array.
Yeah. Yeah.
And made it dedicated. Well, looking at logic, actually just looking at the TTL data book, all the schematics were there. And I came up with an architecture. I mapped it on all the existing IP.
Yeah.
And hey, it fits. Cool.
So you made sure you were covering all
Yes.
the existing things with fewer chips.
Yeah.
Yeah. Which, as you replace those chips, your volume is going to be going up.
Yeah.
Yeah. Which means your price or your profits are going to correspond.
Yeah, as I recall, I kept track of the volume. We doubled every year for like 6 years.
Wow.
Double, 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 double.